Alright, we've got here it's a BTWIN battery, goes inside the bike. It's a 24 volt, 7.8 amp hour. The bike itself is water damaged, so hopefully something interesting in here. Apparently this doesn't work. We're gonna plug the charger in. Plug it into the charge port, light stays green. We get our meter and we test the output terminals. That's 30 volts. But with the charger disconnected, we get basically bugger all. The charger makes a very strange noise. It's kind of wobbly. It's outputting 30 volts. It is a bit much for a 29.4 volt supposed thing, but a functioning BMS should sort that. We will tell the customer that. Let's have it open and see. I'm assuming the screws are underneath this stuff, because there's one there which is probably just a cover for the USB port. Screws. Oh god. Will this just peel off in one? What do we think? No. Great. Well, there's normally a screw about there. There it was. There's one. Probably one on this side in a very similar place. There it goes. That's two. Then I think the bottom should pull off, which it does. There's, I think, the USB control board there. Battery pack itself, IC cells. Something very similar here. Oh, look at that. I'm getting good at this. It's almost like I've done it before. And there's that one. I see disconnected wire. Very interesting. See if we can get it out, shall we? Oh, silicon, of course. I think this USB port is not important to the customer, whether it works or not, so it shouldn't matter. Can have that out. We need a little something to cut the silicon. It's probably very hard to see what I'm doing, but I'm just cutting all this. Trying to anyway, without shorting the entire battery out or slicing my hand to bits, which of course is never good. Will it push? There we go. Right. This sticker here again says 24 volt, 7.8 amp hour, and it's sliding out. Yay. Okay, so this is the USB port you can't see. One day I'll remember to look. This is the USB port cable here. We've got our BMS up here, cells here, LG somethings, M26s. They're, you know, fine. Here's our tiny little JST type connector here. Fortunately, I can't plug it into my lovely balancing machine to check the cells, but you know, these are all labelled, which is really nice. This is BAT 7, BAT 1. And that one says That's 0, which is pretty cool. We like that. Let's have a little look and see. So overall, at the pack we've got, that's our positive there, and our negative is coming into that wire there. Positive to negative, we've got looks like 0 volts across the whole pack. That can't be right. Make sure I'm actually getting the positive terminal there, and let's go right down to the negative of the actual battery pack and have a look under there. There's the negative terminal there. We've got, oh well, that's not enough volts. 100.2 millivolts. That's just completely dead. Wow. To double check that on the balance wires, we've got from our, we've got 1, 2, 3, 4, 5, 6, 7, 8 cables, I'm sure. 1, 2, 3, 4, 5, 6, 7, 8 cables, so yep, they're all here. So between the main negative and the main positive, we have 100 millivolts, which is absolutely nothing, completely dead cells. You know, not good really, not good at all. Just have that out of the way because that's annoying. Very hard to say what strained it. It might have been connected to the bike, could have been left for literally years sitting. I would say it's not a safe recoverable voltage. It's too low for that to be considered safe. You know, would not recommend trying to recover it. Just for the video's sake, we might do it. You know, why not? Get our power supply on. Just going to put this battery's probably going to get hot and be knackered anyway, but let's don't get the fun end. Let's just put 12 volts into it or something like that, just to see if we get any signs of life out of it, or if it immediately starts smoking, because it's a good video. I'm not even going to show you, I'm just connecting this up. Nothing at all. Not to be pulled out of that. Oh, excuse me, hiccups. There's nothing. Well, we've got 6 volts now, so the probably the negative has been cut. So let's just pop it down there onto the cell groups. And the positive by the looks of it too. Okay, power supply is going. 6 volts, 15 volts. If I put this in line with it, you can see what the current voltage that's getting put into it is as well, can't you? In case you're interested. Like that and like that. Probably not making much of a connection. There you go, 15 volts there. Cranking the power supply up. Go up to 20 volts. 20 volts is taking 5 amps into the pack. probably going to get quite warm anytime soon. You never know. Oh, shooting down 4 amps, 3 amps, 3.8, 3.6, and you can see here it's up at 21 volts. That's 3 volt, 3 amps, 2.8, 7. That cell there looks unhappy. Oh yeah. Rusty that. Might be a dead one. May never come up. We'll see. Let's try plugging the charger in and see. Charger still does not want to charge. Oh, the balance wires are unplugged. Might be why. I believe that's back on. Oh. Still nothing. Oh, there you go. And charger has gone red. None of the cells seem really hot or anything. Really, we're just going to probably end up having to quote the customer for a rebuild, which is going to be £200 or something like that, I'd imagine. Yeah, the cells are no longer cold. We don't trust it. I'm going to turn this off anyway, and probably leave it outside in a bucket of sand for a while to just relax itself a bit.